Welcome to Naming Ions. Ionic compounds are composed of ions. So in order to name ionic compounds, we need to learn how to name the ions. So a positively charged ion is called a cation, and the most common charges for a cation are 1+, 2+, 3+, and 4+. Note that in chemistry, charges are always written with a number first and the sign second, because reversing the sign and number, so the sign first and the number second, denotes a slightly different property of oxidation state. A negatively charged ion is called an anion, and the most common charges for anions are 1-, 2-, and 3-. So you need to remember which name corresponds to which charge sign of the charge on the ion. The way I do this is as follows. I have a pet cat. So for me, a cat is a good thing, it's a positive thing. So that means a cation is a positively charged ion. I don't like ants, so an ant is a bad thing, it's a negative thing for me, and this means that an anion is a negatively charged ion. You could also remember that an anion is similar to anti, which means opposed to something, so a negative charge. And you can remember cation and anion however you wish. So we can separate ions into either monoatomic or polyatomic ions. A monoatomic ion is composed of a single atom, so these are things like sodium plus, magnesium 2+, aluminum 3+, chlorine 1-, and oxygen 2-. A polyatomic ion is composed of 2 or more atoms bonded covalently together, and the entire grouping has some charge. So OH- is hydroxide, NO3- is nitrate, SO4 2- is sulfate, NH4+ is ammonium. When hydrogen is bonded with a nonmetal, it generally forms a covalent bond. However, when hydrogen is in a compound classified as an acid, it acts like an H+ ion, like a hydrogen ion, when the compound is dissolved in water. When hydrogen is bonded with a metal, on the other hand, it behaves as an anion, an H- or hydride. Note that we have different names for H+ and H-, even though they're both composed of a single hydrogen atom. Right? The H+ is a hydrogen ion, the H- is a hydride ion. So we need these names to be different so that we can understand each other when we talk. When we're talking about such ions. When we're talking about H+, we want to be able to call it a hydrogen ion. When it's an H-, we don't want to call it a hydrogen ion because that means H+. We want to call H- a hydride ion. So metals compose over 70% of the elements on the periodic table, and in the Earth's crust, most metals are found as ions in compounds. But there are some exceptions to this, including the coinage metals, so copper, silver, and gold. Copper and silver can be found both as ions in compounds and in their elemental states, but gold is found only in its elemental state, because gold is fairly unreactive. In chemical reactions, neutral metal atoms lose 1 or more electrons to form cations, and metal ions are monoatomic except for the mercurous ion, which is Hg2 2+. So we have 2 mercury atoms bonded together covalently. That group has a charge of 2+. So this is a polyatomic ion, which we'll discuss more in a minute. Some metals form only one stable monoatomic ion, while others form more than one stable monoatomic ion. That is, some metal atoms can have more than one possible charge, and others can only have one. Let's talk about some rules for naming ions and their charges. So, metal ion rule number 1 says that the metals in groups 1, the alkali metals, form only one stable monoatomic ion with a charge of 1+. And the metals in group 2, these are the alkaline earth metals, form only one stable monoatomic ion with a charge of 2+. So, lithium, sodium, potassium, rubidium, cesium, and francium are the alkali metals. Those all have a charge of 1+, always, unless they're neutrally charged. Beryllium, magnesium, calcium, strontium, barium, and radium each have a charge of 2+ if they're charged. If they're not charged, then they have a charge of 0. Note that for groups 1 and 2, the charge on the cation then is the group number, positively charged. Metal ion rule number 2 says that the remaining common metals that form only one stable monoatomic ion are silver, which has a charge of +1, zinc, which has a charge of 2+, and aluminum, which has a charge of 3+. The common metals that form two stable monoatomic ions are copper, 1+ and 2+, iron, 2+ and 3+, tin, 2+ and 4+, lead, 2+ and 4+, and the mercury, 2+, and what would be the mercury 1+, the mercurous ion, is our polyatomic Hg2, 2+. So note that both of these ions in the mercury case have a 2+ charge, but the second one is diatomic, so the charge on each mercury atom is 1+. Now the name of a metal ion depends upon whether or not the metal forms more than one ion. For metals that form only one stable ion, then the ion name is the element name. So Na+ is a sodium ion. Aluminum 3+ is the aluminum ion. For metals that form two or more stable ions, the systematic name of the ion is the element name, followed by a Roman numeral in parentheses giving the charge of the cation. So, Fe2+ is the iron 2 ion. Fe3+ is the iron 3 ion. Sn2+ is the tin 2 ion, and Sn4+ is the tin 4 ion. Note that the Roman numeral in parentheses is only added for metals that can have more than one charge. For a metal that can only have one charge, do not include that charge in parentheses. So, for example, for the sodium ion, you don't say sodium 1 ion. You don't write that 1 in parentheses because it's not necessary. There is only one charge, so we don't write it. For the aluminum 3+ ion, we don't write aluminum 3 because all aluminum ions are 3+. So there are 9 common monoatomic ions that you're likely to encounter in a first-year chemistry course, and you should memorize their names and symbols. Hydride, fluoride, chloride, bromide, iodide, oxide, sulfide, nitride, and phosphide. These are the monoatomic anions that you're likely to see. You just need to memorize these. Note that those in the same group have the same charge, and this is because the position on the periodic table, the group, tells us the charge of the most stable ion for the atoms within that group. And also note that the anion name is the root of the nonmetal plus the suffix IDE. So in each of these cases, the anion name is the same as the second part of the word that atom would be if it were in the covalent compound. So if we go back, if we have, say, O2-, that's oxide. This is similar to carbon dioxide. So if we ignore the number portion of that second word on dioxide, if we ignore the dioxide there, is the same as oxide here. So once you've gotten the roots down, for an anion, it's simply the root of the element plus IDE. And again, there are only these 9 common ones, so it's not too many. On the other hand, a polyatomic ion is an ion containing 2 or more atoms covalently bonded together. The charge applies to the entire ion. And there are only 2 common polyatomic cations, ammonia, which is NH4+, and the mercurous ion, the mercury 1 ion that we've already talked about, Hg2, 2+. There are many more common polyatomic ions. So here we have a big listing of polyatomic anions, and you need to memorize these. So the top one here is acetate, then Cn- is cyanide, OH- is hydroxide, MnO4- is permanganate, CO3 2- is carbonate. If we add a hydrogen to carbonate, it becomes hydrogen carbonate, sometimes called bicarbonate. Note that we're adding a hydrogen ion, H+, so the charge of carbonate is still the 2-, but now we have a 2- and a 1+ charge. That means that overall we've got a 1- charge. Then we have chromate, CrO4 2-, and Cr2O7 2-, which is dichromate. Phosphate is PO4 3-. Sulfate is SO4 2-. Sulfite is SO3 2-. Then we've got hypochlorite, chlorite, chlorate, and perchlorate. These are ClO, minus, ClO2 minus, ClO3 minus, and ClO4 minus. So all of those have a -1 charge, and we're just changing the number of oxygen atoms in it. Then we've got NO2 minus, which is nitrite, and NO3 minus, which is nitrate. And last down here we've got peroxide, which is O2 2 minus. So note that there are a few related ions in that table on the last slide, and in every such case, the only difference in the chemical formula is the number of oxygen atoms in the polyatomic ion. And there's a systematic way of naming these ions. So let's discuss that. The polyatomic ion containing more oxygen atoms is named with the suffix ATE, and the polyatomic ion containing fewer oxygen atoms is named with the suffix ITE. So, for example, SO4 2 minus and SO3 2 minus. Well, the one with more oxygen atoms is the one with 4. That's named sulfate. And the one with fewer oxygen atoms, SO3, is sulfite. If there are more than 2 possible ions with varying number of oxygen atoms, then we use both a suffix and a prefix. So we start out with our fewer has a prefix of ite, and more has a prefix of ate, just like on the last slide. Well, if we have even fewer oxygen atoms than the ite, then we have a prefix of hypo and the suffix of ite. And if we have even more than the ate ion, then we have the prefix of per and the suffix of ate. So hypo means less than, so we have even fewer oxygen atoms than the ite, and per is from hyper, meaning more, and that means we have more oxygen atoms than even the ate ion does. For example, our ClO is hypochlorite, ClO2 is now the fewer, so this is chlorite with no prefix. ClO3 minus is now our more, so more oxygen atoms, so this is chlorate. And then ClO4 is even more oxygen atoms, so this is perchlorate. So make the flashcards for all of the common polyatomic ions, both the cations and the anions, and memorize them. So do that now. That was naming ions.